Hey everybody, welcome to chemistry. We have finished up some of our last topic on atomic structure, looking at some details within matter itself and knowing that matter is made of particular elements, and these elements are parts of atoms, and these atoms have subatomic particles, protons, neutrons, electrons. We've learned about the properties of these. Now we're going to look at properties and changes of matter in a more general, bigger terms, such as homogeneous or homogeneous and heterogeneous mixtures. We're going to look at the difference between pure substances, elements, or compounds. And so let's get started with our lecture today. So matter is unique, and in fact every element or compound is unique in some way from others, and so we can get to understand the substance a little better by figuring out what's in it, what information we have about it. And if we know what a substance is, you'll get to learn all sorts of things about it, and specifically types of properties. Just like you are unique with your fingerprint, so is the matter that's around us. And in chemistry, we study this matter and try to determine what the matter is made out of, and we look at the energy that is lost or gained with this matter. So on your notes, you're going to write some key things that are just in yellow here. So we see that matter, as we know, has mass and volume. As we've said, it has mass and takes up space, and space is volume. That is space something occupies. Matter can be either heterogeneous or homogeneous, and sometimes that's pronounced homogeneous. So the big idea for heterogeneous is it's non-uniform, contains regions with different properties than other regions. In other words, hey, you get a mixture that contains more than one thing. If you've ever seen oil land in water, even if you've had crude oil that's been released into the ocean, what does that oil do? Well, it floats on top of the water. We have two layers, so it's non-uniform, and we have more than one layer, non-uniform, and therefore we have what's called a heterogeneous mixture. Homogeneous mixtures, on the other hand, mean it's uniform throughout, appears to be one thing, like milk, or chocolate milk, or salt water, or gold, for example. And what I mean by gold is not the element gold, but the alloy gold that you would use as a gold earring, or a gold necklace, or a gold ring that you would have. So we're going to look at the differences between heterogeneous and homogeneous in a little bit more detail real quickly. And we'll watch this quick little video.
Some of your favorite things are heterogeneous mixtures. It may sound like a scientific term, but its real-world application is super simple. A delicious bowl of Lucky Charms and milk, that's a heterogeneous mixture. Ice cubes in a glass of soda, a big bowl of Halloween candy, even pizza, are all heterogeneous mixtures. It just means that their ingredients or components are not uniform. The components have different properties, and a uniform sample can't be taken across the whole mixture. What does that mean? Dip a spoon into a bowl of Lucky Charms, and sometimes, if you're not lucky, you'll get only milk. Sometimes you'll get the crunchy, crispy things. Sometimes you'll get a marshmallow. And sometimes you might get the perfect bite of all three. See what we mean? A uniform taste or sample can't be taken across the whole bowl. A homogeneous mixture is different from a heterogeneous mixture because the composition of the mixture is the same throughout. Air, coffee, soft soap, even steel, these are all homogeneous mixtures. It's all about the degree to which the components are mixed together and the uniformity of the composition. If you can pick out the components of a mixture the way you can pick pepperoni off pizza, then you have a heterogeneous mixture. If you can't see the individual ingredients and you just see one completely uniform substance, think about the most perfectly stirred glass of chocolate milk, the kind with no syrup residue on the inside of the glass. Then you have a homogeneous mixture.
So we get the key differences then between heterogeneous or homogeneous, and either word homogeneous or homogeneous works fine. Do not worry about it. So we're going to be specifically looking first at homogeneous mixtures. So we're going to look at these mixtures first. Sorry, look at it clear. Homogeneous mixtures first. So if we take sand and water, actually I mixed up there. Sorry, we're not going to look at homogeneous first. Let's just erase that. And normally I would replay this whole video and do it all over again, but I'm not going to do that this time. I'm just going with the flow like it's a normal lecture in class. So heterogeneous mixtures. Two or more materials not distributed evenly, and they're separated by physical means, like Lucky Charms we saw a second ago. Another example of that would be sand and water. You go to the beach, you kick up some sand, and you see that it's all mixed together. However, eventually, because that sand is more dense, it'll settle back down to the bottom of the ocean floor, and we have a heterogeneous mixture, more than one layer. Here's some other examples of heterogeneous mixtures. I usually stop in the morning before I leave and get a granola bar out of the drawer. And so granola bars are heterogeneous mixtures. If I took a piece from over here, or a piece from right there, or a piece from right here, every sample could be a little bit different. It's not the same throughout. Same thing with our salad here, or our cup of ice water. There's more than one layer. We know that we have a heterogeneous mixture. Now, if we compare that to homogeneous or homogeneous. Homogeneous meaning the same throughout. So homogeneous can be mixtures or they could be pure substances. So what's the difference between the two? Well, a pure substance is matter with the same composition throughout. It's pure in nature, and we have compounds and elements, and we've discussed those already. We already know that elements are composed of one kind of atom, and a compound is two or more of these atoms combined chemically. A simple example would be good old salt water, right? So if we have table salt would be a simple example. Salt water, sodium chloride, that is a compound. This compound is a pure substance. It chemically is the same whether I find it here on the top of a mountain or on the bottom of the ocean. Salt water is the same no matter what, okay? Compare that to a heterogeneous mixture. With heterogeneous mixtures, we realize, homogeneous mixtures, it is two or more substances that are combined. So it'd be like basically taking some of these things, pure substances, and putting them together. And we get what are called solutions. And some of these solutions could be a solid solution, like I mentioned before, like a gold alloy, or they could be air that you're breathing right now, which contains nitrogen and oxygen and carbon dioxide, mostly nitrogen and oxygen, 78% nitrogen, 21% oxygen. But these solutions that are around us, or water that contains our tap water, it's not just pure water, it actually contains other ions mixed in there. So those are all solutions. They're considered homogeneous mixtures. So we've already discussed elements and compounds, so I'm going to skip past this slide, but it'll be part of your notes, so you can always go back to it and look at it. A simple homogeneous mixture would be salt water. If I take the salt and I take the water and mix them together, I get a solution that if I took a sample from here, or a sample from here, or a sample from here, it's going to be the same throughout. It is homogeneous or homogeneous. Gold. Hey, I want some more gold. Notice 24 karat gold is basically almost 100% gold. Most of the time, people can buy gold pretty cheaply at, 12 karat, which is 50%. If you're buying a little bit higher level gold, you get 18 karat gold, which is 75%. Like most people's wedding rings, for example, will be 18 karat, or 16, or 14, or 12, depending on the type of gold that you purchase at the time. But maybe when you purchase stuff, you want to buy some white gold. Now notice, what does that mean? It means 75% of it is gold, while 25% is platinum or palladium. If you get yellow gold, notice the different things that make it up. So you can get different amounts of gold, and the different elements that mix them up, they're called alloys, and these are all homogeneous mixtures. Even though this might look like, and these are pure gold bars, they do not use those in jewelry, for example, because it's actually too soft. That's one of the physical properties of it. It is too soft. Let's move right along here. So let's look at the difference between a pure substance and a mixture. Well, we know pure substances would be like elements and compounds. And we know that they have certain physical and chemical properties, and some stuff we're going to learn about in just a second. They're always homogeneous. While a mixture, on the other hand, they can have different properties, right? If I took a little bit of the Lucky Charms, one sample over here, one sample there, each of those would have different properties about it. They could be either homogeneous or heterogeneous, because you could have a solution of salt water that is evenly mixed, or heterogeneous, which would be sand and water, for example. So all mixtures are made of pure substances. So we know to make a mixture, we're taking elements or compounds and mixing them together. Please take a look at these, and it says to identify each of the following as a pure substance, homogeneous mixture, or heterogeneous mixture. We have gasoline, a stream with gravel on the bottom, and copper metal. We also want you to identify these three. Are they pure substances, homogeneous mixtures, or heterogeneous? Chocolate chip cookie, chocolate milk, or salt water, table salt. In this case, not salt water, that's just salt. Sorry, just the compound salt. Is that a pure substance, homogeneous mixture, or heterogeneous mixture? Moving along, something we've already gone over, but just a quick review because it's important when we talk about matter. We know that matter can be a solid, which means it keeps its shape and it keeps its volume. It can be a liquid, which means we know it takes the shape of the container, whether I pour the water, the soda I'm drinking into a glass, or if I pour it on the ground, it'll take the shape of the ground. So we know that it takes the shape of the container. It also keeps the amount of volume. It's still the same amount of soda if I drop it on the ground or if I drop it into a can or a glass. Gas, we know it takes the shape of the container and the volume of that container. Remember, if I spray some perfume in the room right now, that spray will go throughout this entire shape of this room and take up all the space in here until eventually it makes it so we don't have to smell it as much because it spreads out. But it takes up the volume and shape of the container. So in your notes, I've given some other examples just so you have those in terms of solids and ice cube, diamond, iron bar, liquids, gasoline, water, alcohol, blood, gas, air, helium, oxygen. Those are all different gases. Okay. States of matter, we know that water can come in 3 states of matter, solid, liquid, and gas, and those are always an easy example. All right, next I want to get into properties. Now, this came off a little weird when on your notes it'll look a little bit easier to see, but you're going to have to realize that the characteristics used to distinguish between samples of matter are called their properties. Again, characteristics used to distinguish between samples of matter. For some reason, when I downloaded this on Notability, it just didn't come out exactly correct, but no problem there. You guys can figure that out. You're just going to write what's in yellow. So there's 2 key types of properties that we're distinguishing between is the point here. There's physical properties, and they describe the appearance. They can be observed anytime. Some examples of these would be color, odor, taste, texture, hardness, surface tension, density, melting point, boiling point. There's all kinds of physical properties of substances. Compare this to chemical properties. The only time that you can recognize these chemical properties is when they're occurring. So they have to be observed during a chemical change. So examples would be something burning, combusting, something decomposing, like an animal on the side of the road, unfortunately, like a squirrel that got hit by a car. Moving on. Physical properties. Physical properties can be extensive or intensive. Extensive properties depend on the amount of the substance you have, while intensive properties do not depend on how much you have. And we'll look at extensive and intensive in a little more detail. Extensive properties would be like volume or mass or weight or size. So obviously, if I took my weight right now at the beginning of the year and then all I did is ate donuts for the next month, my weight would change. And so obviously, since my weight would change and these can change, this would be a extensive property. Compare that to intensive properties, such things as density or melting point or boiling point. It doesn't matter, for example, if I have a small sample of water or if I have the entire swimming pool of water, it's going to have the same density, which is about 1 gram per milliliter. It's going to have the same melting point. Water melts or freezes at 0 degrees Celsius, and it's going to have the same boiling point, which is it boils at 100 degrees Celsius. It doesn't matter if I have a small sample of water, a little tiny glass of it, or I have a pool-sized amount, it's still going to boil at 100 degrees Celsius. So physical properties that are intensive are ones that it does not matter how much you have of it, okay? That's an intensive property. Moving along. I give some other examples of physical properties here that I'll let you read. Color, hardness, flexibility, viscosity, malleability, if you can mold it into shapes like these various rings and this copper pipe here. Moving along. Please list a couple, at least 2 physical properties of this substance. Chemical properties, on the other hand, hey, as we mentioned, chemical properties, the characteristic of a substance that can only be observed during a change that's taking place. So during a change is when we know chemical properties. Some examples of chemical properties would be something able to burn something, if it tarnishes over time, if it rusts, it decomposes, if it reacts with other chemicals, if it's unstable, ability to react with acids or bases. These are some of the chemical properties that we'll observe throughout the year. So please list some chemical properties that you could mention. So some chemical properties of this particular substance you see pictured here. So who cares? Why do we care about some chemical and physical properties? Let me give you a couple examples. Titanium. Titanium is very strong and it doesn't rust. That's why we use it as jet engines. Knowing these physical properties about titanium also lets us realize that because it's rust-proof and it's non-allergenic, we can use it, for example, in artificial joints or in piercings that people get. So knowing these chemical and physical properties of substance can be important. We know that we take vanadium, for example, and we can mix it with titanium, which is a little more expensive, but we can mix a little bit of vanadium with titanium, and it makes it easier to create some cheaper tools that are still very, very strong. So knowing these properties is important. Hey, helium. We realize that helium, one of the great things about helium is we know that it's inert, it doesn't react. And it's great for making some balloons float, right? Because we know that it's less dense than the air around us, which is mostly nitrogen and oxygen. It also is great at making those funny noises when you inhale it. All right, moving right along here. Some stuff we'll be using sulfur throughout the year, but hey, sulfur is found in rotten eggs and onions and garlic, and that's why it has these awful smell to it, is because sulfur has a stinky smell to it. If you ever use a stink bomb, which you shouldn't be using in school ever, you get that horrible smell. It's because that sulfur that's in it. Sulfur is also very flammable, and that's why it's used in gunpowder, for example. Again, knowing chemical and physical properties of substance helps create all these things around us. Chromium, for example, helps us to create chrome-plated things like silverware, old jewelry, or car parts, like many people have chrome bumpers, for example, on their car. So please classify each of these as a physical or chemical property. Awesome. Thank you guys for doing that. So big idea, matter. Matter can be heterogeneous, meaning more than one, or homogeneous, like a pure substance, like elements or compounds. We know that they can be homogeneous mixtures, the same throughout, or heterogeneous mixtures, more than one. And we realize that these mixtures or pure substances have certain physical and chemical properties. Thank you guys. Please make sure you fill in those notes, and you can always go back to this to look at any information you need. You did a great job listening to me again. Have an awesome day.